has problem for accessing the network or getting the files. Anyway, please open the course material. 6th week, titled Two-Dimensional Computer Graphics 1. Next week, we're going to deal with computer graphics issues 2 in more fundamental and theoretical background. But today, we need to handle some technical issues before handling 2D graphics, 2D computer graphics. Firstly, we need to review some background theories from the last weeks. We listed up some important keywords under this terminology. Of course, we are dealing with design, computing, or computation. Computer graphics in 2D, in 3D, even in 4D or ND are available, I told you before. Overall, we call it design computing. Design computing is almost equivalent to other terms. Digital design, CAD, computer-aided design, CADD, CAAD, and so on. There are amount of similar terms here. But anyway, we are dealing with design. Our goal is anyway design. So we need to define design first. That's why I brought up this one before. Design is structured arrangement of design units or design elements. We need to define again design units. They are physical elements that forms a design. Okay? Physical element that forms a design. Keyword is physical thing, physical element. Another one, some non-physical objects. An element of design that a designer can cognitively deal with. It's a kind of conceptual objects, conceptual, some non-tangible objects. Designing simply includes the process of design tasks, design activities. Designing is an act of creating and elaborating a design. That's the terminology, the definition, brief definition about design. We find out some useful keywords here, something cognitive deal with, or sometimes physical element. Your computational model, your design file generated by AutoCAD, SketchUp, even by PowerPoint, they could be physical file, physical elements when you print out, but basically they are some digitally generated files. So computer-aided design is another important keyword we need to define. CAD is an iterative process that converts a designer's intentional model of functional requirements into an extensional computer representation of the final product. That's what I brought up before. So consequently, we encountered amount of abbreviations like this: CAD, CAAD, CADD, SmartCAD, iCAD, KCAD, 4DCAD, NDCAD, and so on. Meaning, computer-aided design, CAD, computer-aided architectural design, computer-aided drafting and design, intelligent or smart CAD. Sometimes we call it knowledge-based CAD. That's why KCAD. And we can append more information. If it's time, we usually say it 4D CAD. Even more information, cost or some process can be appended. So that is why we can define it, ND CAD. So we also tackled some issues about digital design media, focusing on the media. In these three design modes, mode of thought, mode of expression, mode of production, the most important thing is mode of expression, because whatever you're going to generate, create, visualize, they are a kind of outcome, output products you will produce as a result of the mode of expression. Design is always a way of taking thought system and applying them to visual equivalence. Visual equivalence is very important keyword here. Exploiting a medium's unique qualities to maximize meaning. The meaning here is your concept, your ideas. It's not visible except to you. You should visualize it using exploiting what kind of medium. That medium is computer, including hardware, software, operating system, and so on. Specifically, SketchUp, Photoshop, AutoCAD, and so on. But today's computer tool is going to be PowerPoint. Actually, I told you before, we are not going to dealing with some only technical aspects of computer software. Instead, we're going to deal with some theoretical background and behind the technologies. For doing that, we're going to draw some floor plans using PowerPoint today. I'm going to show you and demo you about it in lab exercise hours. When we are dealing with digital design media, several thousands of years, we use pencils or some pencil-like objects. In other words, designed by hand, designed by some human-made tools. But now we are using very, very different human-made tool, computer, just kind of 30, 40 years, thanks to proliferation of IT, information technology. So this is new type of design media, so-called digital design media. As one of the digital design media, we're going to deal with computer software, series of computer software in the class. So let me show you this diagram again. Our goal is anyway design. Human creativity area, creation is very essential, fundamental part of your designing process. To author your idea, your concept, what you created is design authoring process. In that process, design visualization, development, analysis, they are all important using computational processing. And I declared the entire process in this circular shape diagram means design computing. Human creativity area, our goal is always design, especially interior architecture design. Our means is computing technology. Overlapped part between human creativity area with computational process is AI area. That's what I mentioned before. We call it design cognition, machine learning, and so on. Today, we're going to deal with visualization in 2D, okay? So 2D computer graphics, the first class, our focus here is on mode of expression. Now you're going to express your design concept, your design idea. This class doesn't be digging into exploring design concepts, find out your own design ideas. Instead, we're going to focus on how to visualize it using given and predefined concepts, okay? Of course, you can put your own idea, whatever you're going to do. You can apply your unique and specialized ideas, concepts. That's fine. That's welcome anyway. Design visualizations in which domain? Of course, no need to say it again, actually. In the domain of interior architecture design, okay? In our domain, in interior architecture design, how to make design presentations, how to visualize your ideas, concepts. So here is simple description. What's the goal? What's the objective of your design presentation? Simply want to show your design idea and concepts using a communication tool for designers. Okay, usually we know communication tools. Sometimes a book is very conventional and typical communication tool. Of course, oral conversation is very basic level communication tool, and written language, or even through cell phone. Nowadays we are mostly using Katok, SNS, Facebook, whatever. They are all communication tools. But for designers, especially for interior architecture designers, design presentation is one of the major and official communication tool. That is kind of similar to digital design media, okay? This is the medium, what we handled before. In digital design presentation, or just non-digital based design presentation, what you need to get, what kind of elements you need to create. Text, oral conversation, they are all conventional. What are specific and specialized? Diagram, sketch, draft, models, picture, slides, and so on. Sometimes simulation or some animated pictures, animation, multimedia reports, lots of different elements we need to create. We need to take care of some fundamental things first. Plans. In architectural drafting course, you may draw several times plans. In theoretical perspective, what's the meaning of plans? It's kind of embodiment of designers' ideas in a kind of straightforward way. You can express your design functionality, spatial allocation, pedestrian circulation within spaces directly using your plans. Site plan, floor plan. The term plan usually means floor plan. And elevation, section, detail, they all under the classification of plans. But actually previous plans, what's the mean by previous plans? Previous plans usually means drawn by hand. Previous plans emphasized on the effect of plans. That is why in your drafting course, your major focus probably is on line thickness, how to draw line in parallel, how to line in orthogonal, how to draw your line in clean, something like that. Because visual effect was one of the major topics before computer-generated drafting and plans. But nowadays, contemporary plans, so-called digital plans, digitally generated plans emphasized on the contents of the plans. In other words, you don't need to take care of thickness of lines, how to draw lines in parallel with the same distance in array, something like that. No need to take care of that because computers will generate without any errors. If you assign same thickness to entire lines you draw on your plan, they all must be same. No need to worry about them. So visual effects kind of controllable. You can define them using computer interface. So we can keep focusing on the major content, the major story of your plans, okay? That's major difference between before and after. Here I classify some drawings types in certain theoretical perspective. 3 different classifications. First one, formative. Second one, development. Third one, informative. For the formative drawings, formative plans, they are tables, diagrams, sketch, sometimes freehand drawing sketch, and some concept diagram, concept drawings. For the development, we need to prepare floor plans, elevation section, axonometric, isometric, perspective, and so on. Hopefully, you already have learned those development drawing types in drafting course, probably. Anyway, also there are some more drawing types, informative, architectural specifications, material chart, design statements, and so on. They are kind of informative, additional drawings, usually on top of the floor plans or sections, and so on. Let me show you types of drawings. We can simply classify them in 2 different categories. First one is orthographic projection. For your information, I put official term in Korean, orthographic projection and 3-dimensional projection. In orthographic projection, some typical conventional drawings are here. In orthogonal projection layer, you may find out side plan, floor plan, ceiling plan, and any type of floor plan and similar documents. Elevation and sections are also within this classification. Next one is 3D. Projection drawing, axonometric, isometric, and amount of possible different perspectives. In perspective classification, 3 different types. 1-point perspective, 2-point perspective, and 3-point perspective. Probably you experienced drawing perspectives by hand. Really takes time. Very tedious and time-consuming work. Even if you spend amount of time, it doesn't guarantee that perspective is precisely and correctly drawn. Okay? But by using computers, you can do that very efficiently and quickly. That is why you can keep focusing on the content, not on the effect of the visualization or some drawing types and so on. By the way, do you know the difference between axonometric, isometric? Have you learned from the other course? Hopefully. Yesterday I realized some of you know the differences, but anyway, we're going to deal with that too today. Next page shows you types of lines in drawings. Different lines, different line types. Of course, I put some Korean terminology here too. First one, of course, line. Usually solid line and grid lines. Outline, section line, trajectory sometimes. They are all about your drafting. Architectural symbol, something about architectural symbols and some drawing styles. You can use some different line types, even by your CAD and some drafting tools. Exactly same to the work you are doing by hand in drafting course. Of course, another important line is center line and some lines for dimension. These are just for your information. I listed up some important things in this category, in this kind of well-organized structure. But later on, we're going to deal with in actual lab exercises. Let me show you one drawing example. This is hand-drawn diagram, drawn by hand, and that represents a specific floor plan on top of the tracing paper. Probably you experienced something like this. You need to draw on top of given an existing plan using tracing papers. Sometimes drawing by hand is very important and very useful. And then you can convert the plan using computers and produce something like this, done by hand or CAD software. Usually nowadays we use CAD software for generating this kind of drafting images, but it doesn't matter if you can draw something like this by hand. But anyway, it takes really, really long time. But as a freshman, it could be a good experience, I think. But anyway, we're gonna do something similar work using AutoCAD later. But today, we're gonna draw something like this using PowerPoint. Okay. Let me show you the difference between axonometric and isometric. Let's take a look at this plan. Actually, it's the same plan, but this is 45 degree, 45 degree. That means exactly 90 degree for this plan. So this is realistic actually. But in 3D view, that is not that realistic. This one is much better, right? Because intentionally exaggerate the angle like this. 30 degree, 30 degree. In other words, 120 degree instead of applying 90 degree. So intentionally exaggerated, but it looks more realistic. That's the effect of this isometric. So that's very straightforward difference between axonometric and isometric, even by using the same floor like this. How about different type of 3D perspectives? Number of vanishing points, 1 point, 2 points, 3 points. So usually 3 points of perspective is common, but I recommend to use 2-point perspective. I'm going to show you later in the picture. And this one is exploded 3D perspective. Exploded building, very effective in drawing, but actually it's done by hand drawing. Anyway, this one also 2-point perspective, not 3-point perspective, okay? In architectural drawing, we usually use 2-point perspective because it's very professionally looking and effective, visually effective. Let's take a look at this one, this example. This is 3-point vanishing points you can find out. One is above and 2-point left and right. So as a result, this building looks realistic anyway building, but not that looking good in my view. But how about this? This is an example of interior scene from an interior design magazine, famous interior design magazine, BOB, very professional interior design works published in this magazine. But as you see here, vertical lines, all vertical lines in this picture, all parallel, all orthogonal to the ground line. All vertical lines are exactly 90 degree angled from the horizontal line. So this kind of rendering, this kind of sketch, recommended, okay? We're gonna deal with this one again later when we are dealing with some camera options in computer graphics, 3D computer graphics and rendering tools. So 1 or 2-point perspective, strongly recommended for your design presentation. Let me show you some professionals' work, professionals' drawings. for their design development. All day from some architectural design magazine, BOB, and some other books. Let me show you that book later, but today I would like to bring your attention using 3 professional works. This one has its concept diagram, named concept sketch. As you see here, series of houses deployed in this way, parallel, but they pulled up one row and rotated and distorted. That's their design concept. And this is their section drawing with some color fill and objects and the 3D perspective. 3D perspective of this building. Actually, the goal and the design concept or the use scenario, occupants, there are a bunch of more things we need to take care of, but at this time, we will focus on visual representation for developing their design. In here, in this diagram, in this picture, in this slide, we can find out the concept sketch and section drawing explicitly shows the designer's intention. Okay, that's my point. The second one, here is a concept sketch, rectangle shapes combination, and sometimes looks complicated mixture of that rectangle shapes, cubes, but eventually designers provide this kind of orthogonal 3D projection. It's not perspective, it's orthogonal drawing, projection, but in 3D. So in 3D perspective view, some render scene, we can realize this box-shaped building is a kind of cube objects, series of cube objects stacked. Okay, looking like some co-housing building, something like that. Named block A101, intended to be constructed in Russia somewhere. Very visually effective. The third one shows you section drawing. Okay, in this section, there are people. This is human. So you can imagine the height of the building thanks to that kind of human scale dimension. Also, you can find out this building, according to its section, this building is kind of round shape, circular shaped building. So 3D perspective views, we can find out very certain kind of photorealistic renderings provided. But anyway, if you see this kind of shape, interior shape, or just something like this exterior shape, it's not easy to figure out how many stories in this building, or the mass, size, height, floor height, something like that. But thanks to that section drawing, we can realize the scale, the height, the comparative size, dimension, and so on. So this is kind of the major content and the visual effects of drawings. That's why I show you this kind of professional works. This building for China Comic and Animation Museum, designed by NVRDB, very famous architect group. Okay, let's talk about some technical aspects about 2D computer graphics. The first issue is file formats. Probably some of you may know the difference between raster or bitmap images and vector images. An image from Wikipedia, I would like to show you this one. This bottle and 7 times magnification of this area. If you can find out this one, and this one, simply the Wikipedia describes in this way, and sometimes this is true. Vector graphic generates something like this. But if it's bitmap, we can find out pixels. Okay, so that is kind of salient and important difference between vector graphics. But let's talk about a little bit more detailed issues. Usually vector graphics, we call it line work, because all the lines should be mathematically defined, okay, in terms of its geometry. But raster bitmap image is a kind of dot matrix. Dot matrix means dot by dot. The term dot here means pixel, right? Pixel by pixel defined. So line work, usually we can connect vertices so that we can draw lines. Enclosed lines generate surface and so on. And we can fill colors, something like that. Some formative, constructive approach for generating this kind of 2D graphics. How about raster images? This is an example of dot matrix. Actually, LED matrix. You may know something like this. 1, 2, 3, 4, 5, 5 and 7. Total 35 lines, 35 dots are defined, and we can control dot by dot, one by one, so that you can visualize something. That is fundamental way of defining raster or bitmap images using in that domain. So raster images defines, okay, here is the smile face image, magnify it, and 3 points. 3 points means 3 pixels. 1 pixel, the first pixel has red 93%, green 93%, blue 93%. This one generates something like light gray color. How about this one? Yellow one, R90, G90, blue 0%. This is a basic RGB system of computer, light system. So total 100% RGB returns exactly white color, okay? At this time, this one makes yellow color, something like that. So that is how raster images generate 1 pixel. Okay, another example, 3000 by 4000. That's me, actually, drawn by hand in the class 2 years ago. Don't do except focusing on the class, something like this, okay? Anyway, drawn by hand using Photoshop. Someone who didn't take any courses or knowledge about using Photoshop. Anyway, take a look at this one. Even if we enlarge, zooming in a specific part, this one looks okay because the size of the picture is 3000 by 4000. In other words, really, really large sized image, even if it's in raster, bitmap size. But if you use 300 by 400 pixel, when you zoom in a specific part, that's going to be looking like this. We can see the pixel, okay? That's the problem. So my recommendation is, anyway, we're going to use 3D vector graphics software. But when you generate raster images using specific renderers or screen captures, whatever, you have to generate comparatively bigger images, such as 3000 by 4000 images, something like that, okay? That's my recommendation. Here I list up some image file formats. As you know, there are two different types, raster or bitmap formats and vector formats. On the raster formats, famous JPG, GIF, and PNG images are here. And there are some more formats, TIF, RAW, BMP, and Photoshop PSD files. They are all bitmap format. But blue background formats are kind of commonly used formats. JPEG, very famous when you are using internet, web browser, you may find out amount of JPEG images. Also GIF, PNG. Actually, I recommend to use PNG because JPEG is very good, high compress and full color, but it cannot represent hollow background. In other words, empty background, transparent background. All should be filled with colors. For example, white color, okay? But GIF can make some transparent, translucent background, translucent part among images. But the problem of GIF is only 256 colors can be represented. So that is why I recommend to use PNG, because PNG can represent full color, including translucent part. You can represent some transparent background, okay? What kind of vector formats? We can take a look at in two different categories, 2D and 3D. On the 2D, AI, Adobe Illustrator file, it's kind of Photoshop-like software, but very different. Even if they are from Adobe Systems software, Photoshop is basically bitmap, raster, image-based graphic tool. But Illustrator is dealing with vector-based graphic. But they are all within 2D, two-dimensional computer graphics category. In 3D, there are a bunch of well-known types, or well-known in future for you, to you guys. DWG, AutoCAD file, DXF, SKP, SketchUp file, and 3D Max file, 3ds file, IGS step, IFC, and so on. The green background here, they are some kind of BIM specific file. You don't need to take care of right now, but we're gonna use SketchUp. Actually, you already submitted SketchUp file, SKP, and we're gonna deal with some DWG files, very common files. They are all vector formats, but when you capture the scene, capture the view, they're gonna be one of the 2D raster formats. Also, there is compound, some hybrid file formats, such as EPS or PDF file. You know PDF. I uploaded PDF files for course material on the course website. PDF files contains vector images such as line drawings or fonts. Typing, texts are all in vector, but some raster images can be added. That's why we say compound format. Also, I would like to show you some resolution chart. You know, screen resolution, number of pixels on this one, width and height. Take a look at this rectangle shape. CGA 320 by 200, the smallest one described here. You may know 1080p, full HD. Probably at your home, you have full HD TV. Full HD TV has this number of pixels, 1920 by 1080. The height is 1080 pixels. So that is why we call it 1080p. P here means pixels, okay? That's how we calculate digital screen resolution. So this line represents 4:3 traditional PC monitors, the computer monitors over there. But the monitors in front lines, they are all 8 by 5 wide monitors, computer monitors. And this one, 16 by 9 ratio digital HD TV. We don't need to know the details about it, but at this point, you should take care of number of pixels, width, and its height of your image, raster image, okay? This slide shows you some comparison between different devices, screen size, just for screen size, not device size, okay? Screen resolution. In terms of resolution, if we assume pixels are exactly same, iPhone 4 is here because its resolution 640 by 960, something like that. Actually, I would like to show you another one about DPI and PPI. DPI means dot per inch. PPI means pixel per inch. Actually, for printing device, DPI usually very important. You may heard about 300 DPI required for better quality printouts, something like that. But my point here is you don't need to take care of DPI or PPI. What you need to take care of is simply number of pixels for your image width and image height, okay? That is very important because we can control DPI. PPI, actually, it doesn't matter for your design work. For controlling DPI, you can change, enhance DPI when you get very high resolution images. So you can change DPI using Photoshop or some Photoshop-like computer graphics software. Screen resolution and size of screen, they are different. I displayed this simple matrix, high resolution here and low resolution. In other words, some HD, full HD resolution and very low resolution. But screen size can be vary by your devices. Sometimes very large scale screen you can find out. For example, this one. This screen, this monitor has bigger than 80 inches. But this monitor is 27-inch monitor. But screen resolution exactly same. This one also 1080p full HD resolution. And your monitor also has same resolution, full HD. That means the pixels, the size of pixel, different. You cannot find out the pixels whenever you see your computer monitor screen, but you can realize, you can find out pixel points when you see this screen in certain close-up view, okay? Usually low resolution and small screen, very cheap, but very expensive one is here, really high resolution and large screen. But sometimes even if it's small screen, very expensive because so-called retina display, something like this MacBook Pro or some other devices which adapted retina display. Because of high density PPI, very small size pixel devices on the screen. That is why we cannot differentiate actual pixels whenever we see the screen monitor. That is why it's expensive. So this page simply shows you the difference between those several things. Okay, I think now we are ready to move on to real demonstration and lab exercises for today's technical lab exercise after break, okay? So please take a nap and wake up.